Alright, so we're going to go through an example of how to identify key values, key features, and then sketch a truncus. Okay? So we're going to be looking at this guy right here. Y equals negative, so negative is all, kind of included in our A there, 4 over x minus 3 quantity squared plus 1. Okay? So the first part of it, as it says here, is to state the values of A, H, and K. Remember, those are really important because they help us to identify our asymptotes, which are pretty crucial in drawing this graph. So remember, our standard form is f of x equals A over x minus h quantity squared plus k. So in this scenario, our A is both the 4 and the negative, so our A is negative 4, okay, meaning that this truncus is going to be in quadrants 3 and 4. Our h, well, what's being subtracted from the x? Well, that's positive 3. And then the k, well, what's outside of it all is just 1. Okay, so this h and k, they're the really important part. They help us to identify our asymptotes. So our vertical asymptote, remember, it's always of the form x equals h. So in this case 3. And our horizontal asymptote is always of the form y equals 1. Okay. We do have enough to do a basic sketch of the graph right now. Okay, so we know where our asymptotes are. It's in the bottom half, so we kind of get a good sketch. But it does ask us to state the key features, including the intercepts. So we're going to go through, identify the y and x intercept, okay, if they exist. So what we're going to go through first is the y-intercept. So if I plug 0 right in here, I get y equals negative 4 over 0 minus 3 squared plus 1. That's negative 4 over 9 plus 1, or 5/9. For those of you who like your decimals, that's the erase one there. Let's try that again. Okay, you're looking at, that's about 0.5 repeat. Okay, so just above 0.5. And then our x-intercept, if they exist again, we set y to 0. So I get negative 4 over x minus 3 squared plus 1. Again, we start from the outside and work our way in when we're solving for x. So we start by subtracting the 1 over. So I get negative 1 is negative 4 over x minus 3 squared. And I'm going to multiply this up. So basically multiply both sides by that expression there. So I end up with negative x minus 3 squared is equal to negative 4. Divide both sides by negative 1 to get that I have x plus 3, minus 3 squared is positive 4. Now I can take the square root, but we always remember when I take a square root, I get both the plus and the minus. Square root of 4 is 2. Adding 3 over, I get 3 plus or minus 2, so I get that x can be 5, or x can be 1. Okay? So I've got really all I need now. So I've got my asymptotes, y-intercept, and both x-intercepts. So now at this point we can start putting all of that on the graph. Okay. So let's sketch one out here. Okay. Let's get this in full view. Okay, so I've got x-intercepts at 5 and 1. There's 1 there, 1 here, let's call that 5. Halfway in between those at x equals 3, remember, we have our vertical asymptote. Alright, now I don't have a dotted line function here, so I'm just going to draw a solid line, but draw yours dotted. Again. Okay, so halfway in between at x equals 3. And then again, our horizontal asymptote is at y equals 1. Again, make sure you draw yours in dotted lines. I apologize that mine is not. Okay. And our y-intercept, it's just hiding there, is about just below a half. So if this is at y equals 1, this is at x is equal to 3, our y-intercept is going to be just about there. Okay, so that's at 5/9, or about 0.5. Okay, now I've got enough to draw my graph. Okay, so starting over here, and remember you always want to be moving towards, so it doesn't look great here. Try that again. Better. We want arrows on the end because there's no domain restrictions. Okay, we always want to have our graph going towards our asymptote, and we want this to be as symmetrical as possible. And there we go, I've got my graph. So I've got it going through my x-intercepts, my y-intercepts, and according to my asymptotes. Okay, so this is the graph y equals negative 4 over x minus 3 squared plus 1. Okay, and you can always check this on the CAS by just typing that directly. Again, this is a function, so you can just enter it as a function. Okay. It is worthwhile noting A, H, and K won't necessarily always be this easy to identify. Just for example, you could get something like 1 over maybe 8x minus 4 squared. Okay, so do remember, if we don't just have x, we do need to factorize that out. So you could have to do something like this, where you've got 8, so that you're left with just x. And then here I end up with minus a half. Okay. Check that 8 times x is 8x, 8 times a half is 4, which will become, remember the 8 gets squared, 64 x minus a half squared. Okay, so do be careful when there is something in front of the x that you do need to factorize that out, and when you factorize it out, it's still being squared. So if you want to pull it directly out front, you would have to square it. Okay, so in this case our a would be 1 over 64, but those are special cases. Okay, but we do want to be able to graph it when we're given this transformed form. All right, there we go.